Hi everyone, this is 3.1 linear or not, due on Thursday. So linear functions we've already talked about, and they are straight lines. And what's particular about them is that their y values, if we look at a table, add or subtract, this is super important, by the same number. It's add or subtract. That's the key word. And another word for that is a constant rate of change. So let's take a look. On the left here, both of these are linear functions. We can see that they're linear because they're both straight lines. So these are linear. And this is linear. On the right here, though, this is not linear because it's not a straight line. And we should know that this is a quadratic function. On the right here, this is also not linear. This is actually a cubic function. It's not a straight line. Let's scroll down. In our table, if we look at our second piece of the definition, our y value should be adding or subtracting by the same amount. So if we look here in the y values, it's going up plus 2, then 2 to 4 is plus 2, then 4 to 6 is plus 2. Now, it is going up by the same amount, but I also need to make sure my x's are going up by the same amount. Plus 1, 2 to 3, and then 3 to 4 is also plus 1. So this one, because it has the same number that it's adding each time, and because it's also adding by the same number on the x's, both of these together tell us that it is linear. Okay, let's check on the right. 1 to 4 is plus 3, 4 to 5 is plus 1, and then 5 to 7 is plus 2. Right away, I don't even have to check the x's because I can see that they're actually also going up by 1, just like the previous table. But we see that the y values are different. They're different. So they're not adding by the same amount. The differences. So because they're adding by different numbers, it is not linear. Great. The same thing is true when we look at blocks and patterns. So in the first one, what I want to do is write down how many blocks are in each. So in this first stage, there's 1 block, then there's 2 blocks here, then there's 1, 2, 3 blocks, and then there's 1, 2, 3, 4 blocks here. And what's happening as this pattern is increasing is it's going up by 1. 1 to 2 is plus 1, 2 to 3 is plus 1, 3 to 4 is plus 1. Because it's going up by the same amount, it is linear. Adding by same number each time. Let's look at the blocks on the right. There are 2 blocks in the first figure, 1, 2, 3, 4, 5, 6 blocks in the second figure, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 blocks in the last figure. So between each figure, 2 to 6 is plus 4, 6 to 12 is plus 6. Already we can see that it's adding by different amounts. So it is not linear. Okay? And the last piece is, how can we tell if something's linear? Just by looking at the equation. So in the first one, y equals negative 3x plus 8. It is linear because the x only has an exponent of 1. It's an imaginary exponent of 1. So because it's in the form y equals mx plus b, which is a linear form, it's linear. The same is true in function notation. The x here has an invisible exponent of 1. So this is also in the form f of x equals mx plus b, which is linear. On the right here, these are not linear. Y equals x squared plus 6. Take a look at how the exponent is 2. Okay, the highest exponent there is 2. So this is not linear because of that exponent. and it's actually quadratic. This one here, even though the x has an exponent of 1, it has these absolute value bars. These absolute value bars tell me it's not linear, it's absolute value. So this is not just a straight line, it's actually an absolute value. It's a V shape. Okay, so that's it for linear. If you have any questions, make sure to write them down below. And see you guys tomorrow.